This is Physics 2211 Lab 1 Charged Tapes. The introduction. So the purpose of this lab was to observe the interactions between charged tapes and between the charged tape and other objects, determine the charge on one piece of tape, and make a model to simulate the interactions between two pieces of charged tape. Our findings were that the charged tape has a positive charge. The charge of the tape is 6.06 times 10 to the negative 8th, and the tape has lost 3.79 times 10 to the 11th electrons. So the gravitational force near Earth's surface is the mass times the gravitational constant in the j hat direction, where the gravitational constant is 9.8 meters per second squared and m is mass. So, and then Newton's third law is objects in equilibrium apply equal and opposite forces to each other. The electrical force is that K times Q1 times Q2 over the magnitude of R squared times R hat is the electric force, where K equals 9 times 10 to the 9th. Q is the charges of each particle, and R is the vector pointing from the source of the force to the place where the force acts. This is also known as Coulomb's law. The key assumptions made in this experiment were that both tapes have the same charge, the tape acts as a point charge located at the center of the tape, and air resistance is negligible. So the experiment, the system was that the U-tape that was suspended, the surroundings were Earth, and the U-tape that was held. Part of the procedure was that we charged the two U-tapes by ripping them off of a base tape. We observed the interactions between the two U-tapes and one U-tape with a charged plastic object and one U-tape with your hand and stuff like that. And then we suspended one U-tape between two objects and held the other U-tape under the suspended U-tape and observed their interactions relative to the separation distance between them. Our observations were that two U-tapes repel, the U-tape in the hand attract, the U-tape with a charged pen attract also, and we know that the pen is negatively charged due to the fact that we charged it by rubbing it in hair. The friction with the hair strips electrons from the hair onto the surface of the pen, which would make it negatively charged. And so since the pen is negatively charged and it's attracted to the U-tape, we can conclude that the tape is positively charged. And here on the right, I have free body diagrams for the suspended U-tape and the held U-tape. They both have an electric force and a gravitational force acting on them, but they are in equilibrium because they're not moving. Here's our data and a little picture of our setup. Our tape length was 0.15 meters. Our tape width was 0.019 meters. The tape surface area was 0.00285 meters squared. The number of atoms is the surface area divided by the atom area, which is 2.85 times 10 to the 17th. Distance between the two tapes was 0.15 meters once we observed a change. The tape weight was 0.00015 kilograms, which was solved using the equation provided for us in the instructions. The gravitational force on the suspended U-tape was the weight times the gravitational constant, so that would be 0.00147 in the negative j hat direction. And the electric force on the suspended U-tape would be the negative of the gravitational force since the tape is at equilibrium. Here's the code. Part 1 is the constants up on that top picture, which were all mentioned on the previous slide, plus like the K value for the Coulomb's law and the charge of an electron. Part 2, that second picture, is the gravitational and electric forces. Their calculations for forces on suspended U-tape using the equations from the physics principles slide. Part 3 was solving for the charge, missing electrons, and number of atoms, and then also setting up like the pictures for the model. And we use Coulomb's law for that, also the ratio of the charge to the charge of an electron to find the missing electrons, and then the total atoms, which was mentioned in the previous slide. Here is the code output. As you can see, you have the top tape suspended up there with the red and green arrows coming from it. They're about equal. And then down below it is the held U-tape, which is represented by that other point charge. So since the tape is positively charged, we know that it loses electrons when it's ripped off the base tape, and the net force on the suspended tape must be 0 because after it floats up, it remains at the same height. So the magnitudes of the electric and gravitational forces must be equal. Some possible sources of error could have been mistakes in measurement, like the tape length or the separation distance, or the tape was handled too much because it would lose some charge if it's handled too much, and maybe some error during calculations such as rounding. And then we might have the held U-tape might have not been exactly parallel to the suspended U-tape. So what if electrons had a positive charge and protons had a negative charge? Since the tape loses electrons in the experiment, it would lose positive charges if this were true and therefore become negatively charged. The results would not change since you would still be bringing like charges in contact, so they would repel. Why is it important to handle the charged tapes as little as possible? When the charged tape comes into contact with other objects, it can transfer its charge over to other objects and therefore lose its charge. Thank you for watching.